Hey, welcome everyone. Today we are diving into something really exciting, which is the Microsoft Agent framework. If you're a .NET developer and you have been wondering how to properly add AI agents into your applications, then you're in the perfect place. By the end of this video, you will have a clear understanding of what the agent framework is, how it actually works, and why Microsoft built it in the first place. So without further ado, let's jump right in. Before we jump into the solution, let's take a quick step back and understand the real problem. Over the past couple of years, developers have been playing around with AI agents like crazy. Building quick prototypes is actually pretty easy, but taking that prototype and turning it into something reliable and production ready, that has been really painful. There are three main reasons why it has been so difficult. First, the tooling is super fragmented. You have got Semantic Kernel, AutoGen, LangChain, and a bunch of others, each with their own different APIs and ways of doing things. Second, what works perfectly fine on your local machine often breaks apart the moment you try to deploy it into the cloud. And third, most of the frameworks are missing proper observability, security features, and good support for long-running processes. Microsoft saw all these pain points and basically said, we can do that. We can do these things better. And that's exactly why they created Microsoft Agent Framework. So what exactly is the Microsoft Agent Framework? At a high level, it is an open source framework that makes it significantly easier to build, orchestrate, and deploy AI agents. One of the things I really like about Agent Framework is that it works consistently whether you're coding in C# or Python. That's a huge win for teams that use both languages. Right now, the framework is in release candidate status. That means the APIs are stable and official full release is just around the corner. It's also being actively developed on GitHub, so you can follow along and even contribute if you want. And here's the thing, which is important to know. This is not a brand new framework built from scratch. It actually comes from the same Microsoft teams that created Semantic Kernel and AutoGen. So it's built on years of real-world experience and lessons learned from those earlier projects. Now, a question I get asked a lot is, where does the agent framework fit compared to Semantic Kernel and AutoGen? Here is a simple story. Semantic Kernel gave us solid enterprise-grade features like things like session state, type safety, and great telemetry. AutoGen, on the other hand, brought us really powerful and flexible multi-agent patterns, along with some cutting-edge search ideas like Magnetic One. The Microsoft Agent Framework is basically the best of both worlds merged together. It comes from the same teams, combines the strength of both, and then adds even more on top like graph-based workflows, better interoperability standards, and much cleaner enterprise controls. So if you are already using Semantic Kernel or AutoGen, here is the good news. Microsoft has published clear migration gates for both. You are not starting from scratch. You are simply upgrading to the next generation. The Microsoft Agent Framework is built around two core concepts, agents and workflows. Think of agent as an individual AI workers, and each agent has its own LLM brain. It can call tools, connect to external systems through MCP, and handle multi-turn conversations with users. Basically, it's a self-contained unit that can think, make decisions, and take action. Workflows, on the other hand, are all about coordination. They let you connect multiple agents together in a smart way. Workflows are graph-based, which means you can visually define the order and logic of how agents work together. If you already know LangGraph, you can relate this. You get full control. You can add checkpoints, human approval steps, and easily mix sequential and parallel execution. I know it's a bit complicated, so let me make this super concrete with a simple example. Imagine you are building a travel planning assistant. You might have one agent that understands the user's request. Say, I want to go to Paris next month. That's a user's request. Another agent that searches for flights, and a third agent that finds good hotels. The workflow is what connects all of them. It might say, first run the input agent, then let the flight and hotel agents run in parallel. Finally combine everything into one nice response for the user. So the agents are individual workers doing smart stuff, and the workflow is the boss that coordinates who does what, and basically who does what, when and how the results flow together. Together, these two building blocks let you build anything, which means anything from a simple chatbot all the way up to complex multi-agent enterprise systems. So how does an agent actually work? It's pretty straightforward. The agent receives input from the user, sends it to the LLM along with its instructions, and if needed, it calls tools to get things done. Then it comes back with a response. Simple on the surface, but incredibly powerful once you start using it. Let me make this concrete with a quick example. Imagine you are building a customer support agent, and a user asks like, "Hey, what's the status of my order?" The agent takes that message, passes it to the LLM with its system instructions, and the LLM decides it needs more information. So it calls a tool, maybe a simple C# function that checks your order database. Once it gets the result, the agent responds naturally to the user with the latest status. That's a full loop in action. Now to really understand how it works under the hood, there are a few key concepts you should know. The first one is instructions. This is basically your system prompt. It tells the agent what its job is and how it should behave. Tools, they are just regular C# methods that you give to the agent. The LLM decides when and how to use them. Next concept is session. Session keeps track of the conversation history, so the agent can remember what was said in the previous turns. The next concept is middleware. This is super useful. It lets you intercept request and response. You can use it for logging, adding safety guardrails, or even custom tracing. And finally, when it comes to LLMs, you have tons of flexibility. You can use Azure OpenAI, regular OpenAI, Anthropic Cloud, local models like Ollama, and more. Basically, it can use any kind of LLMs. Workflows are what take AI agents to the next level. Instead of relying on a single agent to handle everything and make all the decisions, workflows let you build smart pipelines. Multiple agents or your own custom code can work together in a structured and predictable way. The building blocks are actually pretty simple. Executors are the processing nodes. These can be full agents or just pieces of your own logic. Edges are connections between those nodes. They control how data flows from one step to next. Now let's make, I know this definition is a bit complicated, so let's make this concrete with a real, let's say invoice processing. Imagine your company receives invoice as PDF files, and every invoice needs to be extracted, checked, approved by a human, and then stored it in your system. That's a perfect use case of a Microsoft agent workflow. Let's walk through it. Step 1. The first executor receives the PDF and extracts all data from it. Things like vendor name, the amount, the line items, etc. The executor does its job and then hands the result to the next step. And step 2, a validation executor. It takes that extracted data from step 1, and validates it. It validates different things like maybe does the invoice number exist, are the amounts within expected ranges, is the vendor registered, etc. If everything looks good, it passes it forward. Step 3, that's another agent and basically an executor, sends it for approval. And this is where something really interesting happening. The workflow pauses and it does not continue automatically. It literally stops and waits because a human needs to look at this invoice and say yes or no. That's what we call human in the loop. The workflow engine holds the state, keep everything in memory, and just waits. Could be 5 minutes, could be 2 days. When the approver clicks approve, the workflow wakes back up and continues. Step 4, the final executor. It takes the approved invoice and writes it to your system and complete the process. Now, what makes this really powerful for production is the stuff running underneath all of this. Checkpointing means that after each step completes, the state of the workflow is saved. So if something crashes, say storage step fails because of maybe database is temporarily down, you don't start over from the scratch. You just resume from where it stopped. And streaming means your UA can show live progress as this is happening. The users can exactly see where the workflow is at any given moment. And that's it. That's the ender sequence. The 4 executors, the edge connecting them, the human process in the middle, the checkpointing underneath, and that's a Microsoft Agent Framework workflow. It's just a graph of steps with framework handling all the hard production stuff for you. The Agent Framework comes with 4 built-in orchestration patterns, and each one maps to a real-world scenario. Let's break them down. Sequential is the simplest. As the name suggests, everything runs step by step, one agent after another. Think of a content creation pipeline. First, a writer agent creates a draft, then a reviewer agent checks it for accuracy, and finally an editor agent polishes the tone and grammar. Each steps build on the previous one. Next one is concurrent. So concurrent is all about speed. Instead of waiting for one agent to finish, multiple agents run in parallel. For example, imagine you are building a travel app. One agent fetches flight options, another checks hotel availability and picks up local attractions, all at the same time. Then you combine the result into a single response. This is perfect when tasks are independent and you want faster results. Handoff is where things get more dynamic. Here, one orchestrating agent decides which specialist agent should handle a request. Think of a customer support system. A user submits a query and the main agent analyzes it. If it is a billing issue, it routes it to a billing agent. If it is a technical issue, then it hands off to a troubleshooting agent. So instead of one agent doing everything, you delegate to the right expert. And finally, group chat is the most collaborative pattern. Multiple agents work together in a shared conversation. Imagine a team of experts solving a problem. One agent suggests a solution, another critiques it, and the third refines it further, going back and forth until they reach a high quality answer. It's like having a panel of specialists brainstorming together. And the best part, all of these patterns are production ready with built-in streaming support right out of the box. One of the most exciting parts of working with the agent is giving them tools, which makes LLM to do more things which is beyond its knowledge. For example, get data from your database. By default, LLM is not capable enough to connect your database and get data out. That's why you're giving tools. In the code logic in the tools, which will have the code to connect your database and get data out. And LLM can that tool and it will get data out using the tool. Basically, the concept is by giving tools, we are giving more capability to the LLM beyond its default or built-in capabilities. Agent framework support 2 main ways to get agent tools. First one is function tools. You literally just write a C# method and add a description attribute, as you can see in the slide, and the framework handles everything else. The agent reads the description, decides when to call it, and the framework manages the schema and invocation behind the scenes. You can even connect to any existing REST API by just giving it the OpenAPI specification. The framework will automatically turn that API into usable tools for your agent. Let me give you a quick example. Imagine you want your agent to check the weather. You write a simple C# function called getCurrentWeather that takes city name and input parameter and returns the temperature. You add a clear description like get the current weather for a given city. That's it. Now the agent can intelligently decide on its own when to call this function during the conversation. The second way is through MCP, the Model Context Protocol. This is an exciting new emerging standard that allows agents to connect to all kinds of external tools and resources in a consistent and standardized way. The agent framework comes with a built-in MCP client, which means you can easily plug in any MCP compatible server, whether it's a file system, a database, search engine, or custom APIs. All can easily connect with the built-in MCP client. As you can see in the example, we are connecting to GitHub MCP to get access to GitHub tools. Even better, Microsoft is hosting a growing collection of MCP tools directly on Azure AI Foundry. So you can start using powerful tools without having to set everything up yourself. What really sets the agent framework apart from most hobby-grade tools out there is its enterprise-ready feature set. The first one is state management. State management is completely pluggable. Whether you want to use Redis, Azure AI Search, or Pinecone, you can easily plug in the memory solution that scales with your production needs. The next one is telemetry. Telemetry is built right in using OpenTelemetry. That means you get full distributed traces and metrics automatically. No extra code required. Then there is the middleware pipeline. This gives you powerful control over every single step of the agent's execution. You can add logging, rate limiting, guardrails, or any custom logic your production environment demands. On the safety side, responsible AI features like prompt shields or personal identifiable information detection those are seamlessly integrated with Azure AI Foundry. And when it comes to identity and security, it works natively with default Azure credential. That means no more hard-coded API keys in your production code. You just use managed identities. That's the professional and standard way, because we don't need to have any API keys within us. Finally, deployment flexibility is really excellent. You can run it on Azure Container Apps, AKS, on-premise servers, or even other clouds. It's totally flexible. The framework doesn't lock you in any single platform. One of the things I really love about this agent framework is how flexible it is when working with model providers. You can basically plug in almost any major LLM you want, like whether it's Azure OpenAI, a regular OpenAI, GitHub Copilot, Anthropic Cloud, AWS Bedrock, or even local Ollama model for offline development and testing. The best part, your agent code stays completely unchanged. You just swap out the client behind the scenes. That means you can start prototyping super fast on your laptop using local Ollama model, and then later switch to Azure Open API for production or a normal Open API. The good thing is without touching a single line of your agent logic. This kind of flexibility is really huge, especially on long-term projects where the requirement, cost, or performance needs can change over time. Alright, let's jump into the code and see what this actually looks like. And I have to say it's pretty clean and pretty easy to do. To get started, you just need to install two NuGet packages, azure.ai.openai and Microsoft agents.ai.openai, both with the pre-release flag, since the framework is still in preview at the time of recording this video. Once that's done, here's a full code to create and run your very first agent. You start by creating an Azure OpenAI client using your endpoint. That endpoint could be the endpoint your Azure Foundry models, for example, and Azure CLA credential. When you use Azure CLA credential, please make sure to log in to Azure using AZ login. Then it takes that credential to authenticate. No hard-coded API keys. Basically, you are not storing any API keys anywhere in the code, which is really great for security because it uses the credential which you logged into Azure using AZ login. Then you call get chat client function to select your model. In this case, I'm using GPT-4o Mini, and simply chain using as AA agent function with a short instruction. You can give any instruction. In this example, I'm giving you a friendly assistant. As soon as when you give as AA agent function or chain your function with as AA agent, it will become an agentic function. And to actually run it, just one beautiful line, await agent.run async with whatever questions or whatever instruction you have to the LLM. In this case, what's the capital of France. That's it. Two methods are doing most of the magic here, as AI agent turns any chat client into a full agent, and handles the entire request and response for you. A question I get asked a lot is, when should I actually use an agent and when should I use a workflow instead? The answer is actually pretty simple once you think about it. Use an agent when the task is conversational or open-ended. This is where you want the LLM to think, reason, and decide what to do next on its own. Think of chatbots, personal assistants, research helpers, anything where the user might ask unpredictable questions or the process is not fixed. On the other hand, use a workflow when you need a structure and predictability. If your process has clear, well-defined steps like approval pipeline, a customer onboarding flow, or an automated report generator, all those processes pretty much predictable because we know the steps upfront. So a workflow gives you explicit control and makes everything much easier to audit and maintain. And here's a really helpful rule of thumb straight from Microsoft Docs. If you can solve the task with a plain old function or even just a simple if statement, then probably you should go that way. Don't reach for AI just because you can. It's a great reminder that even though agents are really powerful, they're not always the right tool for the job. The agent framework is not meant to be used in isolation. It's designed to fit smoothly into the broader Microsoft ecosystem and open standards. One of the coolest things is agent-to-agent protocol, that is A2A. It's a standard that lets agents built on different frameworks talk to each other in a structured way. This becomes really powerful in a big enterprise setups where you might have multiple agents running across different systems, and those agents might need to communicate to each other. Then A2A is the right fit. Then there is AGUA, that stands for Agent User Interaction Protocol, which gives you a clean, standard way to connect your front end and receive real-time events from the agent. It's perfect if you want to build a responsive, streaming user interfaces. For production, Azure AI Foundry is where you deploy and manage your agents. You can even debug and visualize your workflow directly in the portal, which is a total game changer when you are troubleshooting your agents. If you are building for Microsoft 365 like Teams or Outlook, you can publish your agents straight into those apps using Agents SDK. And for running agents in response to events, Azure Function works now pretty well. Plus, the VS Code AI tool could give you an excellent local development experience, so you can iterate pretty quickly. All right, let's wrap this up with 5 key takeaways from this video. First, the Microsoft Agent Framework is basically the next generation of Semantic Kernel and AutoGen. So if you have used either of those, this feels like the natural upgrade path. Second, everything in the framework revolves around 2 main pillars: agents for smart, open-ended LLM-driven tasks, and workflow for structured, predictable, multi-step processes. Third, you get 4 powerful orchestration patterns right out of the box: Sequential, Concurrent, Handoff, and Group Chat. And they all support real-time streaming. Fourth, this framework is truly enterprise ready from day one. You have got pluggable state management, built-in open telemetry, middleware, responsible AI safety features, and native Azure Identity support. Fifth, it works with many major LLM providers. And the best part, your agent code stays exactly the same. You just swap the client. If you're ready to get started, hand over to the official Microsoft documentation and check out the GitHub repo. You can see the URLs here. And in the next video, we are going to build our very first agent in C# together, step by step from the scratch. So stay tuned. And thank you so much for watching. I'll see you in the next one.